This is the screencast for chapter 16 and 17, and in these two chapters we are going to look at some non-renewable energy resources and then just some more efficient methods, which would more look at renewable, but some non-renewables too. Okay, so starting off, we're going to take a look at the idea of the big party we've been having for the last 150 years or so, and this is all based upon oil. Started off with coal, but what really kind of got us going into high gear is oil. So just looking at the amount of oil that's out there, we can say, within reason, that we're starting to run a little bit low. How long will it all last? Most projections kind of put it out there between 40 and 75 years or so, depending on usage. But we can get an idea of just get a look at how much is out there, just looking if we were to strictly use, one particular location's oil. For example, we sometimes talk about we should open up drilling into Alaska's Arctic National Wildlife Refuge, and how much would that give us? There's a lot of money to be made up there because there is oil, but based upon demand, there's really not as much oil up there as we might think. So is it worth sacrificing that area for that amount of time's worth of product? Question to be asked. This next little section here is looking at the infrastructure, the cost. Not really looking at that, but just to point out, I think it's in the reading I saw either in our book or someplace else, that this structure here, the height of it is the height of the, I want to say they said the Sears Tower, Willis Tower I guess we call it now, and the Eiffel Tower combined, I guess looking from this height to this height. But you get a rough idea looking at this tanker here, how large that is. But think of the cost that goes into building a structure like this. And this is an oil platform. There's a little video, I left that out, that really shows you what goes into the production of some of these things. So you have to spend a lot of money to go after this oil. Are there other options? That's the question. So these are some of the choices that we need to make. So, interesting. Where does our energy come from? Well, we start to think, depending on what perspective we're taking, we could say oil, coal, but ultimately the vast majority of our energy comes from the sun, that giant fireball in the sky. Very, very little of it actually comes from fossil fuels, which of course come from the sun as well. But when you look at commercial use, you really get a better idea of what we're doing here right now. Listing here 76% of our energy comes from non-renewables. So we're very much dependent upon this limited material that kind of makes the world go round. So that's fine for now, but we really need to be looking more to the future as far as sustainability. Alright, here's a little picture that kind of shows you all the various types of energy resources. Nice quick little picture. I'm not going to spend a lot of time on it, but it'll give you a little idea as far as how we kind of go about things. Whether we're looking for coal or natural gas, oil, geothermal. Go ahead and pause it if you like and take a look at some of these different drawings. Alright, I really like this graphic here. They both look pretty similar to each other. You can see, for example, this is the world's usage of coal, and here's coal usage in the United States. So we're not much different than the rest of the world. Natural gas, pretty similar. World and us. The biggest difference that we have here is this one right here. The world uses about 33% or relies on 33% of oil for its energy use. We rely on 39%, so quite a bit more. And the other part I find very, very interesting here is we like to think of the United States as, more technologically advanced. We're better. We're ahead of the game on a lot of different things that we do. But this is the one that really stands out as far as the renewables. We use 8% of our energy resources coming from renewables, where the rest of the world is 10% higher. Now there's goods and bads to that. The bads would be on the world side. They're looking at biomass, so that's deforestation, and of course that's not a good thing on a couple different fronts. But when you look at the other parts to it, we use 3%, just 3% of our energy production comes from solar, geothermal, and hydro, where the rest of the world, not as technically advanced as us, more than twice as much. So that's definitely a problem. We have the financial means, we have the technological means, but we're not utilizing them. And I would say it has a lot to do with the money that goes into this, the investment that goes into the substance, the profits to be made. So we are definitely using that while the money's out there to be made. All right, some comparisons for how we use this energy. There's a little definition, vocab, net energy, which is the amount of energy you have to put in versus the amount of energy that comes out of it. And based upon what you're using it for, they have different comparisons. We'll look at a couple here. By far, the best usage for space heating your home would just be to let the sun come in. In other words, direct usage. And you know this yourself. Even on a cold day, if you're sitting by a window and the sun's coming in, days like today, it's about -10, or was this morning anyways, it still feels warm. The sunshine still feels warm. And if you had a concrete or stone floor where that sun's coming in, it's going to heat the space up. It's going to release that heat slowly over time. Very efficient. Very nice is natural gas works really well too. And the reason it works so well is you're burning it right in your house, so it's more direct heating. Interesting, all these ones down here at the bottom of the red, they're not very efficient. So when you take a look at like gas heating or coal heating where you're doing it at a power plant someplace, you have to produce the heat, heat a substance, transfer that substance, turn a turbine, have the electricity come all the way to your house and heat up a coil somewhere in your house if it's baseboard heating or whatever you have. It's very, very inefficient, about 1/10 as efficient as the ones at the top. Okay, comparatively, we were talking about coal not being very efficient, but if you're doing something industrial, typically you're burning right on site and you're using that heat directly. Coal is excellent at that. It has a very good net energy content, so it's very good for doing that compared to the other sources you see listed here. It is much, much greater than natural gas or oil or whatever else you want to talk about. Going to transportation, we see that natural gas is just a little bit better than gasoline. And again, we're talking about using it on site. The gas burns in my car, pushes my car forward. And we're actually starting to see these. There's one of these that popped up in Livonia. It's not quite open yet in 2014. Probably will be. A natural gas filling station. So maybe we'll see those in the future as we're moving along. We'll wait and see. Right, as far as energy use, there's two different types of categories we can look at. Primarily, here in the United States, what we mostly focus on is commercial energy resources. We use energy to heat our homes and cook our foods, for transportation. That's what we use it for, which is quite different than subsistence energy, which is pretty much using that energy just to get by. I'm using wood to heat my house directly, and charcoal, which is a wood substance that we've put into these little briquettes. We're using these to heat our homes directly. We're not using it for selling something or producing something. More direct usage. Okay. Crude oil, the stuff that comes out of the ground, that goopy tar-like substance. Those are called hydrocarbons. If you remember from chemistry class, hopefully, maybe. Hydrocarbons, remember you got those carbon chains sitting here, and then they're all surrounded by however many hydrogens it takes to put in there. So I'm not going to put all the H's on there, but H's are all sitting on the ends of these little connections here. That's a hydrocarbon. This one's an alkane. It happens to be propane. But this is the stuff that we're taking out of the ground. Hydrocarbons, petroleum, along with other things as well. But something very interesting is right now we're only about that efficient as far as taking this material out of the ground. But when the price starts to go up, which it may in the coming years, we'll use other technologies which are a little more costly to remove that material out of the ground. So this is something we're probably going to be looking at more of in the future. And we have some of these right now. So for example, you hear commercials on the radio for fracking and how great of an idea it is. We've gotten to the point where we're actually having to look at that a little more because of the finances. Okay, we're going to take a break here. This will be the end of lecture number 1.